Hello everyone. So today in this video we are going to discuss about the mechanics of position of pelvis and leg. So this is the position. A weightlifter is lifting a weight W naught. We'll see the problem. A weightlifter is lifting the weight W naught shown. The athlete's trunk is flexed by an angle theta as measured from the upright vertical position. So this is the athlete's trunk and it is flexed by theta, an angle theta. So it is represented very clearly here. So this is an angle theta. The forces acting on the lower position of the athlete's body are shown in this figure. So this figure. By considering a section passing through the fifth lumbar vertebra. So here it is the section of fifth lumbar vertebra. A mechanical model of the athlete's lower body is illustrated in this figure, along with geometric parameters of the problem under consideration. So W is the total weight of the athlete. W1 is the weight of the legs including the pelvis. So W0, as already told, it is the weight lifted by this weightlifter. Okay. W plus W0 is the total ground reaction force applied to the athlete through the feet at C. So this is at C, and at B, W1 is acting perpendicularly downward, and at C, W plus W0, this is ground reaction force. So it opposes this force. So it acts perpendicularly upward. Fm is the magnitude of the resultant force exerted by the erector spinae muscles supporting the trunk. So this is the Fm. And Fj is the magnitude of the compressive force generated at the union of sacrum and the fifth lumbar vertebrae. So here this is the union of sacrum and the fifth lumbar vertebra. Here the force Fj is acting, and Fj, as mentioned, is a compressive force. So the direction of Fj is towards the pelvis, right? And Fm and Fj are two opposing forces. So Fm acts in opposite direction. The center of gravity of the legs, including the pelvis, is located at B. Hence, W1 acts perpendicularly downward. Relative to O, the lengths of the lever arms of the muscle force, lower body weight, and the ground reaction force are measured as small a, small b, and small c respectively. That is the distances between them. See here, OA, the distance between OA is small a, OB and OC is small b and small c. See, small b is not the parallel distance here, but it is the perpendicular distance. Drop a perpendicular from O, drop a perpendicular from B, measure the distance between them, it is small b. Drop a perpendicular from O, drop a perpendicular from C, the distance between them is small c. Assuming that the line of pull of the resultant muscle force exerted by the erector spinae muscle is parallel to the trunk, determine Fm, Fj in terms of small a, small b, small c, theta, W0, W1 and W. So by saying this, these are not concurrent forces. That is, all forces are not passing through the same point, but they are acting in different points. So it's just parallel set of forces. So as it is a parallel set of forces, we have to find the moment equation. So we have to find the moment equation at O. What is the moment formula? Moment formula is distance into force. So A Fm, small a Fm, plus B W1, and C is opposing force. So minus C into W plus W0. Here we want Fm. So by sending all other terms to other side, we'll get Fm is equal to C multiplied by W plus W0 minus BW1 by A. Alright? C. We'll just go to here, this one. Fm is inclined as well as Fj is inclined. So as the forces are inclined, they are resolved into their vertical and horizontal components. So Fm is resolved into Fmx and Fmy, and Fj is resolved into Fjx and Fjy. Here we are going to discuss what is Fmx and what is Fmy. So Fmx, this is opposite. So this is opposite. So it is Fm sine theta. Fmy, it is adjacent to theta. So Fmy is Fm cos theta. So we are done with the moment equation. What is left over? That is force equation. So we have to find the force acting in x direction as well as summing force acting in y direction. So summation Fx is equal to 0. First, in x direction, there are only two forces if observed. They are Fmx and Fjx acting in opposite direction. So Fmx is equal to Fjx. This is the first equation. Next, sigma Fy equal to 0. So in y direction, we have Fmy acting upward, Fjy acting downward, W1 acting downward, W plus W naught acting upward. So we can write the equation as downward forces, sum of downward forces is equal to sum of upward forces. So Fjy plus W1 is equal to Fmy plus W naught, right? But here we want Fjy. So we can send W1 to other side. So we get this equation Fjy is equal to Fmy plus W naught minus W1. Now we got Fjx and Fjy from these particular equations. Here, Fjx and Fjy. So if we get Fjx and Fjy, we can get Fj by root over Fjx whole square plus Fjy whole square. So with this, we have done with today's video. So if are you facing some difficulties in understanding or having some queries, please drop in the comment section. Thank you. Please do like, share, comment, and subscribe our channel. Thank you.